Analyze the relationship between pKw and the equilibrium constant. Kw, the water autoionization constant, is related to pKw by the logarithmic definition pKw equals log Kw, which can be rewritten as Kw equals 10 to the power pKw. Because of the negative sign in the definition, a smaller pKw value corresponds to a larger equilibrium constant, Kw. Observe the trend in the provided data table. As the temperature increases from 0 degrees Celsius to 40 degrees Celsius, the value of pKw steadily decreases from 14.9 to 13.5. This indicates that as temperature increases, Kw increases from 10 to the power minus 14.9, approximately 1.26 times 10 to the power minus 15 at 0 degrees Celsius, to 10 to the power minus 13.5, approximately 3.16 times 10 to the power minus 14 at 40 degrees Celsius. Determine the enthalpy of the reaction. Since the equilibrium constant Kw increases as the temperature increases, the forward reaction, autoionization/dissociation of water, is favored at higher temperatures. According to Le Chatelier's principle, an increase in temperature shifts a reaction in the endothermic direction to absorb the added thermal energy. Therefore, the dissociation of water is an endothermic process, delta H greater than 0, which disproves option A. Relate Kw to the ion concentrations in pure water. Pure water must be neutral, which means that the concentration of hydronium ions, H3O to the power plus, is stoichiometrically equal to the concentration of hydroxide ions, OH to the power negative. H3O to the power plus equals OH to the power negative quad, substituting this neutrality condition into the equilibrium. Expression for Kw gives Kw equals H3O to the power plus OH to the power negative equals H3O to the power plus to the power 2 quad, taking the square root of both sides. We find the concentration of hydronium ions in pure water. H3O to the power plus equals square root of Kw equals 10 to the power pKw to the power 1 divided by 2 is equal to 10 to the power pKw/2 quad. Formulate the pH of pure water as a function of pKw. Taking the negative logarithm of the hydronium ion concentration gives the pH. pH equals log H3O to the power plus equals log 10 to the power pKw/2 equals pKw over 2 quad. Calculate the pH of pure water at different temperatures to identify the correct trend. At 0 degrees Celsius, pH equals 14.9/2 is equal to 7.45 at 20 degrees Celsius. pH equals 14.2/2 is equal to 7.10 at 40 degrees Celsius. pH equals 13.5/2 is equal to 6.75. Thus, as the temperature increases, the pH of pure water decreases, which confirms option D is the correct statement. The correct answer is option D. As the temperature increases, the pH of pure water decreases.